Today we're going to be talking about transformations of functions. And we know what the parent functions look like. It's going to be really important that we understand that when we start to manipulate their graphs. Today we're going to start by manipulating the equations. And location is going to be really important. If you manipulate the outside of a function, that's going to affect the outputs, which are your y values. So I'm going to start with this one out here. If I add to the outside of a function, what that's going to do is that's going to change my y values by making them larger. So this is a shift, or another word you'll see us use is translate. And it's going to cause all of my y's to get bigger, so it's shifting everything up. If I subtract from the outside of the function, it's the same movement, but instead of up, I'm going to go down. Then there's a. So a multiplies to the outside of the function, and it does two things. If a is negative, that means all of my y values change signs because I'm multiplying them by a negative. And graphically, that is a reflection over the x-axis. It flips it upside down. The other thing that a will do is you have to ignore the negative if it's there. So if the absolute value of that a is greater than 1, that is a vertical stretch. And if that a value is between 0 and 1, remember we don't care that it's negative. Negative's the reflection. If the absolute value of a is in between 0 and 1, that is a vertical compression. Okay, so there's the outsides. Now what if we manipulate the insides? Well, this would be changing your inputs or your x values. So C right here is a lot like D. I'm either going to add or I'm going to subtract from the inside. These are still a shift or a translation, but you have to be careful with everything on the inside because it is all opposite of what it appears. If I add to the inside, that's a horizontal shift. So we're moving left and right. And adding, we would think, means to the right, but because we have to think opposite, it is actually moving left. And if we subtract on the inside, we're going to shift or translate to the right. So opposite of what we would intuitively think. Because everything on the inside is an opposite. All right, just like A, if B is negative, this one's going to be a reflection. But it's changing your x values. So this time it's going to reflect over the y-axis. And then it has similar situation for the stretches and compressions, but you have to remember that everything's backwards. If that b value is greater than 1, this is a horizontal compression. And if that b value is between 0 and 1, that would be a horizontal stretch. So all of these are just definitions, and we're going to start to put them into play. So for all of these, we're going to identify the parent function and then what transformations happen. And number 1, our parent function is a square root. Okay, so this is the square root family that would have began as, I named it f of x because I can't name it, uppercase y. You could have done lowercase y equals it. It's up to you. And there are 2 transformations that happen here. And when you list them, you have to think about order of operations. If I were to plug something in for the x, the first thing that I would have to address is this -3. Well, that -3 is on the inside, so it's a horizontal shift, but it also lies to you. So even though it's minus, we think left, this would be right 3. After I subtract 3 from my input, I would square root, but that's the parent, so that's not a transformation. So then lastly, I have this adding 2 to the outside. This would be up 2. And that's the only transformations that occur on number 1. Number 2, the parent for this one is going to be the absolute value of x. And so this would be, this is not writing again. My screen is driving me insane. So it's the absolute value of x. We have 2 transformations here. The first one we would have to address is +4 on the inside. So that is left 4. Then we have the compression out here, and you have to make sure that you say that it is a vertical compression. And we're going to say by 3 because you're taking a third of it, so you're compressing it by a factor of 3. Number 3, our parent function here isn't super obvious, but we have a squared, so we know that the parent is quadratic. And for the number of transformations in this one, there's actually 4. The first one we would have to address is the +3 on the inside. So that one is left 3. Then I would square the value, which is fine. That's the parent function. But then that brings us to this -2. And there's actually 2 transformations shown there. And I don't care which one you write in order. But the fact that it's negative tells me that we're going to reflect over the x-axis. And then now I'm going to ignore that negative. I'm going to look at just the 2, and that would be a vertical stretch by 2. And last but not least, we have the -5 out on the outside, so that would be down 5. Okay, our next one, this one is a rational. Okay, so its parent would have just started 1 over x. This has 2 transformations, and the first one we would have to address is the -2. That's considered inside because it's in the denominator with your x. And so that would be a right 2. And then that +7 would be considered on the outside, so that would be up 7. For these next 2, the parent function is not obvious because I didn't give you one of the families, but notice this is capital F of x equals little f of x. So the original parent would have just been little f of x. We're just not giving it one of the family names that we have talked about previously. There are 2 transformations here. We have the negative on the inside. That would be a reflection over the y-axis. And then the +3 on the outside would be up 3. And for 6, for the parent, this is going to be a lot like number 5. Y would have started with little g of x. And there are 3 transformations here. So the first one we have is on the inside. So we know that this horizontal and everything on the inside lies. So even though it's bigger than 1, we have to remember that is a horizontal compression by 3. And then these next 2 are going to be interchangeable because that outside -2/3, it's a negative. So we're going to reflect over the x-axis. And then the last one would be, I have a 3/2. So that one is a vertical stretch. by 3 halves. Okay. Now we're going to try the same thing, but we're going to run it backwards. So for 7, I want you to write an absolute value function that has a vertical shift up 3 and a horizontal shift left 2. I'm going to name this one y, and I'm going to leave lots of spaces, but I know that I've got an absolute value and x would have to be on the inside of it, and then I'm going to see what would go where. Vertical shift up 3 would be adding 3 to the outside. Horizontal shift left 2 would be adding 2 to the inside. And then that's all this problem had. So this right here would be my final answer. I'm going to do the same thing with 8. 8's a square root function. I'm going to call this one f of x. I'm just going to change its name to get some variety. Okay, and I'm setting it up with all my empty spaces. If I have a vertical stretch by 2, I would multiply the outside by 2. If I want it to reflect over the x-axis, that means that 2 has to also be a negative. And then I have a horizontal shift right 3. So that means on the inside, I'm going to have a minus 3. And that covers them all. All right, and our last one is quadratic. I'm going to name this one g of x. And with quadratics, in order to get that inside part, what I'm going to do is I'm going to create this parentheses and square it so that if I do have to put on anything on the inside, I have space to do so. Okay, I have a vertical compression by 3. Compression means I'm multiplying by something between 0 and 1, so I know that on the outside I'd have a 1/3. I have a vertical shift down 1. So vertical is still doing the output, so on the outside I have a minus 1. Then I have a horizontal shift right 4, which means on the inside I would have a minus 4. And then we're practicing more of these in our homework.